that we actually have two on-site events for additive printed flexible hybrid 3D electronics. One of them, the flagship event happens in Berlin in October every year. And we will also be holding our first US event in Boston in June, in early June. So, save the dates already. I totally forgot to mention this, but you should be aware of that. And hi, welcome on stage.
Hello, Kasha. Pleasure to be here.
Nice to see you. So whenever you're ready, Evan, you may start. He's with Voltera, a really superb company. Actually, they're one of our gold sponsors, and they'll be telling us about printing RFID tags using copper ink on paper.
Fantastic. Well, thank you, Kasha, for introducing me. And hello, everyone. My name's Evan. I'm a hardware developer at Voltera, and I'm really honored to be presenting to you guys this afternoon. Well, it's afternoon where I am, but wherever you guys are. Today, we're going to be talking about printing RFID tags with nano copper ink using our new product, Nova. So just a quick agenda for what we're going to talk about today. First, we're going to discuss RFID technology. This is probably a technology that many of you are already familiar with, but I'm just going to quickly summarize its technology and its widespread use. Talk about maybe some of the issues that exist in the RFID space today, as well as some potential solutions. And one potential solution that we're going to walk through to the development of a better RFID tag, if I dare say, using really neat nanoparticle copper ink, using our product, Nova, as well as some other in-house lab equipment. And then we're going to close out with talking about how the tag performed, as well as some potential future implications of such technology with nano copper inks. So diving right into it, again, many of you may know what RFID is, but in case anyone here doesn't, we'll do a quick explainer. So RFID stands for radio frequency identification. So just a technology that leverages digital communications to communicate small little packets of data between a scanner and a passive tag. Typically, this is used to identify items within many different contexts and track them as well. So today we're going to focus on the application of UHF, or ultra high frequency RFID, which again comprises of what you can see in this image here of a handheld scanner, along with these small little passive tags that you can put on items. This works by scanner emitting certain radiation and the tags sort of backscattering that and communicating that way. This provides some benefits compared to optical systems like barcode scanning, which are often used for tracking, because RFID doesn't require line of sight, and also it has vastly superior range. And moreover, these passive tags, one of the cool implications that I think is really neat about this technology is these passive tags not only can be used in tracking, but the ICs on these tags also incorporate a user space, which can be used by companies to add not only an ID to one of these tags, but also additional information like date of manufacture or expiry date just on the tag itself, rather than having some back-end database that you need to refer to, which I think is really incredible. And of course, we can all probably think of applications where this technology is used, from tracking within logistics systems to manufacturing spaces. Increasingly, we see this technology used as a replacement for barcodes in the consumer space, for example, in high-end retail clothing. But then there's also new applications in spaces like healthcare, where RFID tags can be used to track things like blood bags within hospitals. And just a quick note on the scale of these tags. There are 28 billion tags made in 2021, which is a 36% growth compared to 2020. And though I don't have 2022, 2023 numbers, that trend just keeps going. So this is a very big market. So what's the problem with this, and what's the impetus for this project we're going to talk about today? Well, 28 billion tags plus made a year, small little environmental impacts and costs associated with manufacturing a single tag. Obviously, a small cost impact, a small environmental impact is not a big deal when you make one of these, but when you're making 28 billion, those small little details add up. Currently, most of these tags are manufactured, as you can see in this image, are manufactured using a process of etching aluminum, which is subtractive. So, you have your substrate of PET, adhesive, and aluminum, and